Okay, hello everyone and welcome to our presentation. My name is Jakub and I'm here together with my colleague David. We are working in Red Hat as a quality engineers, and today we would like to share our insights and our knowledge about GitOps approach that we use in our testing environments. At first, let's talk a little bit about the presentation timeline. At first, we would like to get a brief interview what is GitOps and what is the GitOps pattern. Then we would like to share you which other tools we are using, so which platforms we are using, how we set up the platforms, how we do the automation all around. Another step will be cluster management. We don't have just one cluster, we have a fleet of clusters, so it's kind of important to manage these. So this will be another step. And then we will move to ArgoCD and Tekton. One of the main parts is also monitoring and logging, so this will be part of the presentation as well. And some useful insights into Argo Workflows and Argo Events, which are really great tools, and everyone should be aware of it. Then we also prepare some demo, so we will be able to see how our whole infrastructure and basically the whole environment works. And we will also show you some visualization of our metrics and logging that we have depicted in Grafana. Okay, that's it. Over to David.
So let's start with our GitOps pattern. What is a GitOps pattern? It's basically a set of principles and practices which use a Git as a source of truth of all your configuration and manifest for applications. It uses Git as a source control and as a version control. So you always know what the last commit is running on top of your infrastructure and who this commit made. Some key principles. Declarative configuration and manifest for Kubernetes in our application, version control, automation deployment, in our case using the ArgoCD. And what are some benefits? I can highlight the collaboration because there is a great opportunity to share the knowledge between the developers and DevOps. And they all can, collaborate in one repository and share their knowledge. We use a platform, in our case, is a Kubernetes, so all of our application automation and other stuff running on top of the Kubernetes. We have two kind of platform Kubernetes. We have infrastructure part and let's say the data plane part, which is which is a fleet of the clusters. You can imagine it as a production cluster, staging environment, and so on. And for the automation, we use Ansible because we don't like the shell scripting. We love the declarative way how to Ansible declares the steps and other stuff. And also we like the libraries. For example, the Kubernetes libraries for Ansible is great. It allows you to do almost everything. Another part for the managing the clusters, we use the advanced cluster management, which is based on open source project, Open Cluster Management. We have the ability to manage all our cluster fleet. We can spawn or delete the clusters using the Hive. We can perform and control the upgrades of all our clusters, and what is really benefit for us is a central monitoring solution. We know what is happening with the clusters and so on. So let's move to the automation and deployment part. We use ArgoCD. ArgoCD is a GitOps tool for deploying your declarative manifest and operators. We love the native experience, which is a ArgoCD operator. It allows us to simply declare the application set and create the ArgoCD servers. What is also fine is the customized support and the metrics. For the running pipelines, we use a Tekton. Tekton is a cloud-native CI/CD system. All the pipelines, tasks, and steps are declared as a custom resource. So it's easy readable. It's written as a YAML manifest. You can reuse the task between the pipelines and so on. And also it's run inside a Kubernetes cluster as a pod. And the pod of the pipeline can be multi-container. So if you need, for example, the Git tool for downloading and cloning your repository, you use the Git container. If you need the Maven or Java, you use the Maven container, and all these containers shares the work files. And that's yours.
One of the crucial part of our infrastructure is monitoring. I mentioned, or David mentioned, that we have several clusters in our fleet, and each cluster hosts basically different workloads. We are tied, or in our work, we are tied to Streamzy project, and so we use it as a system under test in our workloads. And we are running Streamzy for quite a long time. We are trying to, let's say, simulate the customer environment, try to hit the problems that users could hit when the pods or the workloads on Kubernetes clusters are running for a longer time than just several minutes that we have in our end-to-end testing. To understand potential issues that could occur during the, let's say testing, but it's just running the workload. We have to have proper metrics collected and keep them for some time. To achieve that, we have set up a Prometheus instance on each of the cluster that collects all metrics from each pod that is available on the cluster. This is a great solution. However, we have a fleet of clusters, so it would be nice to have it somewhere in the central point and have it available only just at one place in, for example, one Grafana instance. To achieve that, we have Tenos instance available on an infrastructure cluster that is used as a central point for running ArgoCD, Tekton pipelines, Tenos, logging, and some other stuff. Tenos itself basically communicates with each of the Prometheus instance available on fleet clusters and collect all the data from them and use it in, or store it in a S3 bucket on AWS, or in your specific implementation, you can use, for example, Minio for that. It's basically up to you. These data are then available in our Grafana, so we are able to check what was happening like 10 days ago, 20 days ago. It's basically up to the configuration of Tenos. I also mentioned logging. It's a very important part as well. From time to time, our operator or any different workloads that we have on our clusters basically crash. So it's very important to understand why it happens, what was happening before the crash itself. So we have to analyze the logs. Without any proper solution, it will be kind of hard to get logs, for example, for last, let's say, 2 days. And when we will observe the problem just after some time, it will be mostly impossible to get this. To achieve proper logging, let's say, schema, we use OpenShift cluster logging. It's basically orchestration that deploys a daemon set of vectors. A vector is a tool that running on Kubernetes node and collect all logs from all pods that are running on the cluster. You can also use, for example, Fluentd, which basically do the same thing. These logs has to be stored somewhere. It's a huge amount of data, so to make it working properly, we use Loki stack, which is implementation of log aggregation inspired by Prometheus. Logistack basically stores all the data that are collected by vector in S3 bucket. So again, you can use AWS or any different implementation. It's up to you. And you basically specify the data retention based on your needs. So if you want to have logs from a specific applications to keep them, for example, 1 year, you can do that. And for different application or different type of workloads, you can drop the data after 10 days, for example. It's basically up to you and up your configuration. Loki also have a native integration with Grafana and Prometheus and Kubernetes because it's developed by a Grafana team, as far as I remember. Argo Workflows. David mentioned Tekton, which runs Tekton pipelines in your Kubernetes cluster and provides Kubernetes native experience to running it. Argo Workflows is something very similar. It's a native engine for Kubernetes workflows, so you're able to specify a workflow with specific steps that will be executed on your cluster, or it can connect to different cluster. Again, it's basically up to you and your use case. Argo Workflows allow you to trigger not just via cron, which is great. For example, Tekton doesn't have a cron, so you have to a little bit hack it with cron job. However, Argo Workflows itself has cron support, but what's the most important part here is event trigger. I will talk about it in a few as part of Argo Events. Each step could be executed in parallel in workflows, and you can also share the data between the containers. So you can each step imagine as a container, so you can share data. Each container can wait for results from another container. So it's basically, again, up to you what kind of workflow you want to execute. Argo Workflows allows you do a templating, so you can have one template and then just reference it in different triggers with different parameters and arguments. There's also exit handlers, so in case there is a problem with your workflow, you can call exit handler and get notification to Slack, for example. As a use cases, you can imagine it as a CI/CD system, use it for infra automation or basically for machine learning. Argo Events. Argo Events is an event-driven automation framework. Basically, you have several parts deployed next to the Argo Workflows, and you basically listen to some events, for example, from GitHub, GitLab, Slack, PubSub from Google, Kubernetes events. There's plenty of event sources that you can use, or you can extend the possibility with writing your own and just use your custom one. As part of Argo Events, you also deploy Event Bus. Event Bus is used as a transport layer for events. So basically, you get an event from GitHub. It will be sent to event source that pass it to Event Bus, and then I think it's called sensor. Yeah, the sensor itself will react on the event and trigger the specific workflow based on your configuration. As an event bus, we use Kafka, more specifically Kafka managed by Streamzy. So next to it, we also have an instance of Streamzy operator that manage our Kafka instance for these purposes. This is basically our architecture about Argo Events and Argo Workflows. So as I mentioned, you can see here that the Argo Events, mainly the event source is waiting for some events from external sources. In that case, GitHub, Slack, Webhook, it depends. And then send the messages or the events itself to Kafka. Then there we have two sensors that react on the events that are available in Kafka. And when the event is here, the sensor consumes it and trigger the specific workflow based on the configuration. Here you can see our deployment on Kubernetes cluster. On the left side, you can see Stringy deployment and event bus, which is Kafka. We also have a drain cleaner here, which basically takes care about moving Kafka pods from nodes that are being upgraded to keep Kafka cluster up and running and operational during Kubernetes upgrades. And on the right side, you can see the deployment of Argo Events, Argo Workflows, and some already finished workflows that were triggered by events from GitHub.
Okay, so let's move on our overall architecture, where we will show you how the whole infrastructure is installed on the greenfield. So let's start with the first repository, which is called Automation Hub. There are stored all the Ansible playbooks and ArgoCD application manifests and other configuration and tweaks. And the deployment hub, which stores all the Kubernetes manifest of our applications, which we test and running on production and staging environment clusters. So, firstly, we need the infrastructure cluster. We use the OpenShift, but it's a Kubernetes cluster. And on the beginning, you need to trigger the automation from the repository Automation Hub on your own laptop. So, installation process will install the ArgoCD operator, Tekton, Argo Workflow, and all the other stuff like advanced cluster management, logging, and monitoring. Now, ACM steps in and start to spawn the worker clusters. So the ACM using the Hive install both, in this case, worker clusters. The first one is a staging environment, let's say, and the second one is the production environment. Now the ArgoCD steps in and start getting the files from the deployment hub, because the application and application sets are already in Argo in infrastructure, and ArgoCD start to reconcile it. So ArgoCD deploys the managed apps on the worker cluster 1 and worker cluster 2. In the next step, we have also the repositories from the Strimzy, so Strimzy Kafka operator and Query registry, where the Strimzy Kafka operator images are pushed. Our automation in Tekton gets these changes from the repository and Query, and if there are some changes, let's say on the main branch, it gets the new manifest and images and update files in the deployment hub, which is the trigger for the ArgoCD, and ArgoCD roll out the staging environment and tries to deploy the latest Strimzy Kafka operator. Tekton also contains another pipelines for the running some automation on the worker cluster and worker cluster 2. Let's say in our case right now it's an upgrade. And now you see the Argo Workflow has the new pipeline, the workflow, which gets the data from the automation hub and run the installation process every time when new changes are pushed into the automation hub repository. So we don't need the first laptop for the running the whole automation, but the Argo Workflow will take care about upgrading the infrastructure, infra-cluster applications and operators for ArgoCD, Tekton, and so on. And yeah, and Argo Workflow also, because we need to manage, because we need also some cron trigger jobs, so we implemented some secret copy workflow, which is called periodically, and updates some secrets in workflow cluster 1, 2. And also on infra cluster. Yeah, so let's see how the Argo Workflow UI looks and how it works when we push the new changes into the automation hub. So we have the Git repository, and I opened the PR, which just changed the scale of nodes for advanced cluster security. I merged these changes and opened the UI of the Argo Workflow. So after a short time, the new workflow run will be triggered, and we will see that the Ansible will be run in the pod, and yeah, it's running, and I can also see the logs from the pod in the UI. So yeah, we are waiting for pod creation, and if I open the logs, I can see it. Yeah, after a while, there will be the end of the pipeline, and yeah, we will see the steps. Steps, and the not notify step, which is our notifier for the select, because we only want to see if the pipelines or workflows failed, so we want to have the notification in our select channel. So in case the pipeline is okay, we don't receive the select message. Yeah. A short demo is about the Tecton. I will show you how it looks in OpenShift console, and how looks the pass pipeline and the successful pipeline and the failed pipeline. So the pipeline definition, as I said, is a Kubernetes manifest, so it's defined declaratively in YAML file. You can specify the container for the running the Git and for the running the rest of the steps. We use our own image because we need more tools for running, for example, this pipeline. And if I open the pipeline and UI, I can see there were the 3 steps, and the pipeline was successful. This is the pipeline for updating the manifest from Streamzy in our deployment hub. And I see also that notifier step is skipped because the pipeline was success. The second pipeline is of our small test suite, which just check the application is up and running correctly. You can see the application is not running correctly. This pipeline ran the Java JUnit 5 test using the Maven. The tests are failed, and so the final task, this notifier select, was triggered, and we received a message on the Slack channel about it. Yeah, the notify was triggered. And the last demo is about ArgoCD and the UI of ArgoCD and how it changed the application after the changes in the Implement Hub repository. You can see the many applications which we have managed by ArgoCD. On the left side, you can specify the label. We have the label Streamzy, and also we want to filter the application which are running on the staging environment, which is the worker cluster 1. We will pick the application, the client application. It simulates the load of the messages. We have many of pods of running the simple messaging on the Kafka clusters, and we will be interested in the IoT. In the UI, you can see the old stuff. Also, you can see how the pods are spread across the around the worker nodes, and you can also see the logs and other stuff. If you click, you can see also the number of the pods and so on, which will happen right now, if I'm not wrong. I will speed up a little bit. Yeah, there are the pods. So let's move to the GitHub. There is a small change. We changed the message, the IoT message. I changed the battery level from 99 to 50. And after I merge it, we will see how the Argo quickly behaves and roll all pods of the IoT externals deployment. So we will refresh the UI to see the changes. Now you can see that the application is out of sync and it's right syncing. So yeah, the pods are started rolling, and it will be really fast because it's a simple application. And after that, application is up and running. All pods are running. And if I open the logs from any pod, I can see that the changes were applied, and the message is modified, and battery is on 50 level, on 50%. Yeah. You can also see that what is the latest change, and so we are always sure which changes are running on top of the cluster, and you can play basically with the view and so on. So that's it. Yeah.
Okay, now let's check how our Grafana looks like. We have several different dashboards. Here you can see dashboard that is mostly for Strimzi operator. We are filtering our existing clusters in the Grafana dashboard, so we will get the proper data from Thanos based on this label. So in that case, the cluster value is set to GitOps infra, and the data are about our Event Hub deployment. Next one could look like this. It's a Kafka dashboard that is provided by Strimzi. This deployment is on our worker cluster. It's one cluster from our fleet, and it's basically the latest version of Strimzi deployed as a software under test, where we play with it and check if everything is working fine in the long term. This is Loki dashboard. Loki itself provides a way for going through the logs, so you are able to specify which application or which pod should be picked, and the data will be shown in the dashboard. You can also filter the data, so in case you want to see just info log level, for example, you can very easily filter this out in our dashboard. And this is our custom dashboard about the whole infrastructure and deployed stuff. Okay, let's wrap up. We just wanted to show you that there's a lot of ways how to use great Kubernetes native projects that are part of CNCF, and you can easily manage your infrastructure and your applications with them, even in a great scale, and also in the long term. We are performing zero-touch upgrade. We have metrics depicted in Grafana, and we also didn't mention that we have configured alt manager as part of Prometheus in case there are some troubles with the applications of workflows. We'll get a notification from alt manager as well. Okay, that's it. There are some links, so if you are interested in the configuration that we have deployed in our testing environment, you can find everything on GitHub in GitOps organization. And that's it, and I think we can answer the questions.
Okay, I can take the first one. If you have multiple clusters in production, yeah. Okay, the second one. If you have multiple clusters in production, for example, in 20 regions, how do you... Okay. How do you roll out changes to be able to define strategy for it? Basically, we don't care about it in our testing environment, but there is also another project which is the Argo rollouts, and it can take care about it. So you can specify the rollout policy, and the Argo rollout will take care about it.
How do you manage multi-cluster deployment? Do you have repo for each cluster? Do you copy or somehow extend base configuration? Yes, this is part of our Automation Hub repository. We just specify there some basic configuration, like size of the cluster, which machine sets should be available on the cluster, and the scale of cluster, and Hive instance that is available on a cluster will provision the cluster and set up the configuration on it based on the info from Automation Hub. But you can definitely have the configuration stored in different repository, and in case you want to have different configuration for each cluster, you can achieve that. You can also manage it with Argo if you want. Can Argo Workflows be triggered by BFU? I'm looking for some UI-friendly tool for user-triggered automation. To be honest, I'm not sure what is BFU.
Me neither.
Okay, that's great. I don't think so. You have to have some event or cron defined to trigger Argo Workflow.
No. You can trigger it from the UI. Yeah, it's possible. Just trigger it from the UI, and yeah, it's like a Jenkins or other systems where you can click on the pipeline and it's running.
Can Argo Workflows events be used also for generic event-driven processing and workflow execution, or can it be used only for GitOps and kube management? Definitely we can use it for everything you want, not just for GitOps and kube management. It's just our use case, basically.
And we are also running the testing pipeline on it, So for us, it's a replacement for Jenkins, for example. Okay, so if there is no other question, thank you all for the attention.
Thank you, everyone.